Okay, so SL 1.1 is mainly on scientific notation. So scientific notation, we want to convert a very large number or possibly a very, very small number into the form a times 10 to the power of k, where a is greater or equal to 1 and less than 10, and k is an integer. Now what this means is, if we are given this big number right here, it's very hard to read it or compare it to other big numbers if you want to count the zeros. But if we have a standardized form of scientific notation, we can have this a value here. Okay, we're going to take 3.75 because imagine we're going to be putting a decimal place anywhere in this big number. Now, where should we put the decimal place for a, for this number, to be between 1 and 10? Obviously, we're going to put it here because 3.75 is between there. If we put it in front, it's going to be 0.375, and if we put it after, it's going to be 37.5. So we don't want that. So if we put it here, now we want to imagine how many places do we need to move the decimal place, or how many multiples of 10 do we need to multiply by this number in order to get back to this number, because obviously this is not the same as this. But if we multiply this number by 10 to the power of something, and in this case it's going to be 10 to the power of 5, and I'll show you why in a sec, now they will be equal. Okay, and this is because, let's write this out again, times 10 to the power of 5 is basically timesing 10 5 times, right? So if we times 10 once, we're going to get 37.5, times 10 again, we're going to get 375, and then we're going to do it 3 more times, right? So 1, 2, and 3. And now we get the same number, okay? So that's how you convert big numbers in scientific notation. Okay, so in the case of very small numbers with a lot of decimal places, in this case we have 0.000375. How do we convert that to scientific notation? Well, same thing again. We imagine where we can put the decimal place in order to make it into a number between 1 and 10, okay? And in this case, we can put the decimal place here. Okay, we'll get 3.75. So if we just write this out again, it needs to be multiplied to 10 to the power of an integer in order to turn into this. So how would we do that? Well, obviously, if we have any number greater than 0 or 1 or 2, we are not going to get this number because it's just going to get bigger and bigger. And this is where negative indices come in. So if you're familiar with indice laws, and you should be by now, is that if we take the power of like -2, just for example, it's basically saying we are multiplying by 1 on 10 to the power of 2, or 1 on 100, okay? And that's the same thing as 375 divided by a 100. And if we know we're going to divide some number by 100, we're going to move its decimal place twice to the left. And in this case, we're going to be left with 0.0375. Okay? So how will we get from this number, 3.75, to 0.0375? Well, a trick I like to use is just count how many zeros there are in front of the 3. If there's 4 zeros, you just multiply 10 to the -4. And how we can verify this is, let's divide 3.75 by 10 first, okay? So if we divide by 10, we're going to get 0.375, and we will be doing this 4 times, right? So we get 0.0375, that's twice, this is 3 times, and lastly 0.000375, which is exactly what we began with, okay? And that's the basics of scientific notation. Now, a quick thing to note here with scientific notation is this inclusive greater sign and this exclusive greater sign. So why is this? Why is this not included? Why is this included? Think about it this way. If we put the decimal place here, we're going to get 10 to the power of 10 to the 4, all right? Because there's 4 zeros afterwards. Now, this looks fine, but we can actually simplify it further, because if we write 10, if we want to write 10 into scientific notation, we can actually write it as just 1.0 times 10 to the power of 1 if you wish, right? Therefore, we can actually simplify this further into 1.0 times 10 to the power of 5, right? with, now if we think about it this way, 1.0, 5, so we go 1, 2, 3, 4, 5, there will be 5 zeros afterwards, just like what we began with. And the inclusive part of 1, well, that's also self-explanatory, because if we have 0.001 in this case, we can convert this into, let's say, 0.1 times 10 to the power of -2. But then we can also convert it into the proper scientific notation of 1.0 times 10 to the -3. Now, this has to be allowed, because if this wasn't allowed, we would have to opt to this, which is why this is inclusive and this is not, okay? And I'll reiterate, 10 is not included because it can be simplified once further.